This is part two of organized lists and tree diagrams. At the local custom car shop, they are offering a discount if you purchase a customized package featuring their most popular features and choices. You have 2 rim options, 2 window tints, and 3 paint details to choose from. You must choose one of each to receive the discount. Make a table showing all the possible packages available. So, here are the possible choices. You can choose from the rims, you can choose either rim option 1 or rim option 2. The colors are either dark or light, and the details are dragon, flame, and lightning. So let's create an organized list or tree diagram. Let's see, if I choose a rim option 1, I'm going to choose the dark window tint and the dragon detail. If I choose rim option 1 again, I'm going to make it organized. Don't go haphazard and go all over the place. I'm going to keep the dark window tint and I'm going to get the flame detail. If I have a rim option 1 again, I'm going to get the dark window tint with the lightning bolt detail. Have I exhausted every option with the dark tint? I have. So I keep on going. I'm going to do the rim option 1 with the light window tint and the dragon detail. I'm going to have the rim option 1 with the light window tint with the flame detail. I'm on the rim option 1 with the light window tint with the lightning bolt. Are there any other possible outcomes with rim option 1? I don't think so. I've exhausted all of them. Now let's go to rim option 2. I predict there are 6 outcomes with rim option 2. And I predict, you know what? I can repeat this, but instead of using rim option 1 thing, I use the dark window tint, dark window tint, dark window tint. It comes with a dragon, the flame, and a lightning bolt. I choose the light window tint, the light window tint, and a light window tint. It comes with the dragon, the flame, and the lightning bolt. So how many possible outcomes do you see here? So I just listed all my sample spaces, every possible with this possible choice with this experiment or outcome. So how many possible outcomes or combinations do you see here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that is the answer. Could I have done this with a tree diagram? Is it possible to do it with a tree diagram? Well, let's see. Let me return all these items. I'm sure there's a faster way of doing this, but let me return all this item. So I'm going to create a tree diagram. Dark, dark, dark. Looks like I'm playing memory or something. Lightning, lightning, flame, dragon, flame, dragon. All right, if I start with rim option 2 and rim option 1, those are level 1. From that, I can choose a different type of color. For level 2, I can either choose dark or light. Dark or light. In the 3rd level, I can choose 3 types of details. I can choose the dragon, I can choose the flame, and I can choose the lightning. The dragon, the flame, the lightning. The dragon, and then I'm done with the first tree diagram for rim option 1. For rim option 2, after I choose my dark window tint, in the 3rd level, I could choose dragon, flame, lightning. Dragon, flame, lightning. So, some people think this is faster. I personally prefer the tree diagram. So you can count the number of possible outcomes. There are 12 of them. So John flips a coin and rolls a standard 6-sided die. Make a tree diagram to show all the outcomes. So if you roll a coin, you either get heads or tail. So have we exhausted? Is there any other way, unless it's a trick coin, but we're just talking about a standard coin. What about a die? If you roll it, you get a 1. Roll it, you get a 2, a 3, a 4, or 5, or 6. Are there any other possible with the head? So first of all, you roll a penny and you get a head, and you roll the die. Are there any other ways, different combination? I don't think so. So if I roll the tail, I can get a 1, 2, 3, 4, 5, or 6 for the die. So how many possible outcomes do you see here? I see 12 possible outcomes. I could get head 3, head 5, tail 1, tail 4, tail 5, and so on and so on. Avelina tossed a coin 2 times. Make a tree diagram to show all the possible outcomes. So I have my first coin. So coin 1. I either get heads or tail. If I flip my second coin, after I get heads with my first coins, I flip my second coin. What are the possible choices? I can either get head or tail. If I, however, landed a tail with coin 1, and I get my second coin, I pick it up and I roll it, what are the possible? I can either get heads or tail. So how many outcomes do you see? There are 4 outcomes. Heads, head, heads, tail, tail, head, or tail, tail. There are 4 outcomes. So let's practice with this by drawing tree diagram. Johnny tossed a coin 3 times. Find all the possible outcomes. So coin 1, coin 2, coin 3. So this is going to be 3 levels. The first coin, I flip it, I get either head or tail. When I flip the second coin, I get either heads or tail. Heads or tail from my first coin. If I flip my third coin, I can either get heads or tail, heads or tail, heads or tail, heads or tail. How many possible outcomes do you see here? Head, 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 tail, tail, head, tail, 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 head, head, tail, head, tail, 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 head, tail, tail, tail. There are 8 outcomes. However, Monique missed class today. Explain to her how you could use this tree diagram to determine the number of outcomes of flipping a coin 3 times and getting exactly 2 heads and 1 tail. So, out of the 8 outcomes, how many possible ways can you get 2 heads and 1 tail? I can get it this way: head, head, tail. Is there any other way I could get heads, tail? Oh, I can get it this way: head, tail, head, because there's 2 heads and a tail. Any more? I can get it this way: tail, head, head. That's 2 heads and a tail. And last but not least, that it? 3. So I would tell Monique, after you create your tree diagram, go through the levels and find these possible choices of 2 heads and tail. And here is more neater. So the first flip, I get either heads or tail. The second flip, I get head, tail, head and tail again. If I flip a third flip, I get head or tail, head, tail, head, tail. And I can tell Monique, get head, head, tail. You can get head, tail, head, and tail, head, head. So there are 3 possible ways to get 2 heads and a tail. Marianne was choosing outfits to wear. She has 2 jeans, dark and faded, 3 tops, plain, stripe, and print, 2 jackets, lightweight and heavy. Draw a tree diagram that shows all the different outcomes. How many different outfits can she put together? So she started with dark jeans, faded jeans. That's the first level. In the second level, she has 3 types of tops: plain, stripe, print. Plain, stripe, print. In the third level, she has 2 types of jacket. She can either choose a lightweight or heavy, 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 lightweight or heavy. So how many outcomes do you see here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 12 outcomes here. So what are the 12 outcomes if you want to go specific? So you can get dark jean with plain top with lightweight jacket. Dark jean with plain top with heavy jacket. Dark jean with striped top with light jacket. Dark jean with stripe with heavy jacket. And blah, blah, blah. I'm not going to keep doing it. You can see it through your tree diagram 12. Pages are classified as two types. When you go to the hospital, you're either classified as male or female. And then you are sometimes referred as diabetic or non-diabetic. Then, how do you care for you? Do you total care for yourself? Do you partially care for yourself? Or is it self-care? I guess that's what it means. Well, self-care would be care for yourself. Partial means I guess you have to go to the doctor and do maintenance. And total is you need total dependence, I guess, of a hospital. TPSC. Do not know that. Medical staff would know this. So how many outcomes do you see here? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 12 outcomes again. So again, you have a male who's a diabetic who needs total care. You have a male who's a diabetic who needs partial care. You have a male and a diabetic who needs self-care. But maybe you have a male who has non-diabetic who needs total care. Male non-diabetic with partial care. Male non-diabetic with self-care. Keep on doing it, you'll have 12 outcomes. Make an array. Array is a college word. I did not learn this word until I took linear algebra in college. An array is like a chart that shows an organized list that shows all the possible outcomes for the gender of two twin siblings. Gender means either male or female. If the first twin is a male, he can have an identical twin, which is another male. But what happens, I know I have this in my class, in my 5th period class. You have a male and he has a sister who's a female. But then you may have a female, I know I have one in 2nd period, she has a fraternal twin who's also another female. And last but not least, you have and I have this one, my 3rd period, I have a female twin. And then her brother is in Miss Myers' 7th period class, and that is a male. So these are all the possible genders with two twins. And last but not least, okay. So what we did was we practiced with organized lists and tree diagrams. So with a tree diagram, you can find all the possible outcomes without forgetting anything. Or if you don't like creating tree diagram, you can create an organized list. Again, when you create an organized list, do not go haphazardly all over the place. Make it consistent.